Alright, so the last task was for you to draw out the wave as it goes through each one of these media or as it interacts. So, light as it goes from air to water would actually slow down. So you should have drawn a wave that was going pretty fast and then would have a lower frequency as soon as it hits the water, because water is more dense than the gas, so there's more particles in the way to slow it down. Then light, as it goes from water to air, would be the opposite. So we would have drawn a wave that had a lower frequency, and then as soon as it hits the air or the gas, it would speed up really quickly. Okay, so it goes from a more dense water to a less dense air, so there's less speed bumps in the way for it to get caught up. Okay, sound, on the other hand, as it goes from air to water, would actually speed up because it needs the particles. So it needs those particles close to each other. So the denser it is, the closer they are to each other, and the faster that sound will travel. So we should have showed our wave increasing in speed. Constructive interference would occur if we had a wave, two waves interacting. So one wave had a crest, the other wave had a crest, so they come towards each other, they form an even larger crest. So let's say it's sound, we would have an increase in amplitude, so it would be an even louder sound. Or we could put two troughs together. So the trough of one wave interacts with the trough of the other, those interact and form an even deeper trough. That's another option. So whenever they're on the same side and they interact to make an even larger amplitude of the resulting wave, that would give us constructive interference. Destructive, you would have drawn a wave that had a crest, another wave that had a trough, and when they interact, they cancel each other out. Doesn't always cancel out into zero or no wave. Sometimes it'll reduce the amplitude. So maybe we started off with an amplitude of 2, but our resulting wave only had an amplitude of 1. Okay, so crest and trough interact. They deconstruct or they destroy each other. Okay, so it cancels out. Reflection, we know it bounces back, so it hits a smooth surface, it bounces back. So we would have drawn a wave coming in and maybe hitting a wall and then bouncing back in the other direction. Refraction, it bends as it enters a new medium. So you would have needed to draw some change in medium. So as it goes into the second medium, it bends due to it either speeding up or slowing down. Diffraction, we know that it bends as it goes out a doorway, so you could have drawn a doorway and the sound bending as it goes out the door, or even around the corner, and then it spreads out. So the reason why you can hear somebody yelling down the hallway is from the sound bending out the door and then spreading out as it goes down the hall. Sound as it goes from water to air. Sound requires a medium, so we would have had to draw a wave that was going at a decent speed, and then when it hits the air, it would slow down. Air is less dense, so we talk about in our explanation how the air is less dense, molecules are further apart, there's more space between them, so the wave slows down because it takes longer for the energy to be transferred between the particles. Then finally, sound as it goes from liquid to solid, we know that sound is fastest in a solid, so it's going to speed up as it goes from the liquid to the solid. Solid is the most dense, particles are closest together, so it would be fastest in the solid. Alright, so that's just a brief rundown through our review today. Make sure that you are looking over all of the other review materials, check out all of the other videos, and all of the other items and study guides that are there, and then we will knock this out of the park tomorrow.